Welcome to a lesson with Dr. Powell. Let's take a look at a function and find its Taylor series. Consider f of x is equal to the sine of x minus pi halves. And we're going to look at the Taylor series of this with the center pi halves. Now, what does this mean? This means that when we write out the series, everything will be in terms of x minus pi halves to the nth power. Okay, now there is more than one way to do this, but in this example, we're going to see how to do this using the idea that the nth coefficient, or the coefficient of this particular term, is formed as the nth derivative with the center plugged in all over n factorial. Okay, so let's get going on this. What is this? All right, so I need to come up with maybe a pattern for what this is, what these coefficients are, and then maybe express that as in terms of n. So we got to find a pattern. What are the derivatives of sine? Let's think about that for a minute, because this is the nth derivative. So let's run through the derivatives of sine. We got for n, and let's take n as 0, 1. 0 means you haven't taken any derivative. 3, 4, 5, 6, 7. We're just looking for a pattern. And here we start with sine, then we go to cosine, negative sine, negative cosine, sine, and it repeats, cosine, and so forth. Now realize that we're plugging in pi halves into the center. When we plug in pi halves, that's the same as if we're plugging in 0. So we can just think of plugging in 0 each time. And what we get is, at least for the derivative part, we get 0, 1, 0, negative 1, 0, 1, and so forth. Notice that our series then will have some powers of x minus pi halves, because n represents the power of x minus pi halves, as well as, so this power, as well as how many derivatives you've taken at the same time, as well as the factorial. So notice that for the powers, the even powers, you don't have anything at all. We can represent the odd powers right here by an expression 2n plus 1 if we want. So we could change this table up a little bit and think 2n plus 1, and think of now as maybe our n referring to something else. Instead of referring to the power, let's suppose that it refers to an index, and 2n plus 1 is the power now. So if the index is 0, notice the power is 1, 1, 3, 2, 5. So we just get what we want over here, just picking out the ones that we want, and the rest are zeros. Now, notice that we alternate in sign. Therefore, we could think f, the nth derivative at pi halves, would simply be 1, let's see, what is it? 1, negative 1, 1, and we could represent that as negative 1 to the nth power. Checking at 0, it works out to 1. So we have everything we need to write down our formula. N goes from 0 to infinity, and we're going to have -1 to the n. And then the power we're working with is 2n plus 1, which is also the factorial, multiplied by x minus pi halves to 2n plus 1. And that is our series. Thanks for watching.